Hello, dear students, welcome to this video. Today we begin module number 4 of organic chemistry, that is carboxylic acids and sulfonic acids. This module deals with nomenclature, preparation, physical as well as chemical properties of carboxylic acids, carboxylic acid derivatives as well as sulfonic acids. In this video, we discuss only about nomenclature as well as isomerism of carboxylic acids. This is the general formula of carboxylic acid. As you know, the functional group is COOH. So there are two functionalities. CO is carbonyl group and OH is hydroxyl group. So naturally the name carboxylic comes from carbo, from here, and XYL. So together carboxyl. This is representing aliphatic carboxylic acid. R is an alkyl group, and this represents aromatic carboxylic acid, where AR is the aryl group. Now when we go to the nomenclature first, we know according to UPSC system, for naming carboxylic acid, the last letter E of the pattern name, like alkane, alkene or alkyne, that last letter E is replaced by oic acid. See that there is a space here between oic and acid. And other rules all remain same, like you have to select the longest chain including the functional group, then number the chain according to lowest number rule, giving lowest number for the functional groups, and all other rules are valid here. We consider 4 different types of examples. The first one, these are all aliphatic carboxylic acid containing only one COH group, that means monocarboxylic acids. The simplest carboxylic acid, as you know, is HCOOH. So it contains only one carbon, so the word root is meth, right? And it is only carbon-carbon, single bond, only one carbon, so it is alkane, so methane. Then for acid we add oic acid by removing this E, so it is methanoic acid. So this is methanoic acid, okay? And what is the second one? 2 carbons, so ethanoic acid. 3 carbons, so propanoic acid. And this is butanoic acid, pentanoic acid, etc. Now regarding the position of the functional group, you know, up to 2 carbon we need not mention any position. When it is 3 and we number like this 1, 2, 3, start giving lowest number for carboxylic group. So this can be called propan 1 oic acid. Position of acid is 1. So propan 1 oic acid. But it can be simply called propanoic acid. That means position 1 can be omitted. Why? Because for carboxylic acid always you get position number 1. It is because in carboxylic acid group this carbon has only one leftover valency, right? 2 double bond, this is a double bond and a single bond, so 3, so only one valence is left out for COH group. So it always come at the end. Naturally get position 1. So that is understandable. So wherever the position is unambiguous, if it is well understood, it can be omitted according to IUPAC recommendations. Okay. Now, in addition to IUPAC names, many carboxylic acids have got very popular common or trivial names. Sometimes common name is more popularly used than IUPAC names. For example, here, what is methanoic acid commonly called? You know that, formic acid, isn't it? Formic acid. ethanoic acid, commonly called acetic acid. Okay. Propanoic acid is called propionic acid. Butanoic acid is commonly called butyric acid. Okay. Butyric acid. And then pentanoic acid is called valeric acid. Then hexanoic acid is commonly called caproic acid, etc. And these common names have some meaning in it. They are related to their origin. As you know, formic acid, it comes from formica, red ant. Acetic acid comes from acetum, means vinegar. Butyric acid from butyrum, which means butter, like that. Now, second set of examples here, you have some branches or substituents. So when you name them, according to IUPAC rules, you have to select the longest chain. Okay, here the chain is nothing but the straight chain, no other chain possible here. And you can see there are two substituents. This is bromo, this is methyl, and numbering, of course, starting from here 1, 2, 3, 4, 5. So it is 5 carbon parent name, that is again only carbon single bond, so pentane, and oic acid, so pentanoic acid. Now the substituents are to be prefixed, bromo and methyl, alphabetically to be arranged. So it is 4-bromo, right? 4-bromo hyphen 3-methyl pentanoic acid. Okay. The next example. Here it's important that when you select the chain, it should include the carboxylic carbon. So this is how chain is to be selected, right? Not the straight chain, even though it is longer. Numbering starting from this carbon 1, 2, 3, 4, 5. Again, it is pentanoic acid. Okay, there is no carbon-carbon multiple bond, so it is alkane only. So pentanoic acid. Then you have a substituent, that is ethyl. This is ethyl group at position 2. So 2-ethyl pentanoic acid. Okay. Now coming to the next one. Here, this is the bond line representation, the simplest way of drawing structure of organic compounds. This represents CH3, Okay. Now, here this is the carboxylic acid group. So position 1 for this carbon, then 2, 3, 4 and 5. So in addition to carboxylic acid group, there is another functional group, that is keto group. Okay. So what about the name? Again it is 5. So it is pent. It is not pentane but pentene, double bond is there. Position is 2. So pent 2 enoic acid, isn't it? Pent 2 enoic acid. Okay. And what about the prefix? At position 4 there is keto group. So it is to be written as prefix 4-oxo or 4-keto, you can write as well. 4-oxo pent 2 enoic acid. Okay. Coming to the next set of examples. What about these carboxylic acids? What is the speciality? They contain 2 COH group, or they are dicarboxylic acids. And this is the homologous series of dicarboxylic acids. This is the simplest one, 2 COOH. This is only COOH. It's a very, very popular compound. What is it? What is COOH? That is H2C2O4, which is nothing but oxalic acid. That's a common name. Oxalic acid. And here there is a CH2 in between. So the next homolog member, homolog COOH, CH2COH. Okay. What is this called? This is called malonic acid. Malonic acid. The next one more CH2, that is called succinic acid. Okay, succinic acid. The next one is called glutaric acid. The next is called adipic acid. Okay, these are common names. Now, what about IUPAC names? The IUPAC name goes like this. See, 2 carbons, so it is ethane, right? It is ethane. Okay, and then when there are 2 acids, you have to call dioic acid. You have to use the numerical prefix di, and one difference here is that here when such di-tri comes with inside, you should not drop this E. So it is ethane dioic acid. Okay, ethane dioic acid. If you keep the position strictly, it is ethane 1,2-dioic acid, but that is not necessary. Now here, what about the position? It is 1 and 3. So what is it? 3 carbon, so it is propane. Okay, it is propane 1,3-dioic acid or propane dioic acid. Okay, what about the next? This one, it is 4 carbon, so butane dioic acid or butane 1,4-dioic acid. It goes like this. Now the last set of examples. What about this specialty here? These are all cyclic compounds. This is alicyclic and these are all aromatic. Okay. Now, in cyclic system, the point to be noted is that the carboxylic carbon doesn't come within the ring. So, when you name it, it is to be explicitly shown. You have to use a special suffix here. Okay. The first one. What is the parent name? What is this ring? Cyclohexane. You cannot call this compound cyclohexanoic acid. Why? Because that doesn't include this carbon. Because when you say cyclohexanoic acid, the implication is that there are 6 carbon, cyclohex, but there are 7 carbon. So in the ring system, this carboxylic acid is to be suffixed separately, explicitly. So the name is cyclohexane. Okay, cyclohexane, and this is named as carboxylic acid as such. So cyclohexane carboxylic acid, that's the name. Cyclohexane carboxylic acid, right? Now what about this one? This is to be called benzene carboxylic acid, but IUPAC has accepted special names for aromatic compounds, and this is called benzoic acid, simply benzoic acid. What about this one? Benzoic acid is the parent name. There are 2 substituents, and this is methyl position. This is 1, this is 2. So what is the name? 2-methyl benzoic acid, right? And this 1,2 position is commonly called ortho position. So this and there is a single name for this compound. These 2 together called toluic acid. Okay, toluic acid, because this is toluene, right? Methyl benzene is called toluene, and benzoic acid together toluic acid, and it is ortho to each other. Ortho toluic acid. See that it can have 2 more position isomers. Which are they? You can place it at the meta and get meta-toluic acid and para-toluic acid. You draw the structures in your notebook. Now next one. This again, this is benzoic acid. Parent name, position 1 and 2. So what is it? 2-hydroxy benzoic acid, and it has together a single name that is again a very popular one, salicylic acid. Salicylic acid. Okay, again this is the ortho isomer. It can have meta as well as para. Coming to this one here, this is to be named as an aliphatic derivative. So then we call this as phenyl. That is more convenient. So 2-carbon acid, it is ethanoic acid and phenyl. Phenyl ethanoic acid. Coming to this one, Okay, so this is phenyl ethanoic acid. Here it is dicarboxylic acid, so you can call it, strictly speaking, benzene 1,2-dicarboxylic acid. Or there is a single name, common name, that is phthalic acid. Okay, this is called phthalic acid. See that this is the name for the orthoisomer. 1,2 position or orthoisomer is phthalic acid. If you change the position to meta or 1,3, then it is called isophthalic acid. You have to add iso to this, then it is meta isomer. And if it is 1,4 or para position, you have to add terethalic, it is terethalic acid. Okay, so if it is ortho, it is phthalic acid only. If it is meta, then isophthalic acid. If it is para, it is terethalic acid. And finally this one, whenever acid is connected to the aliphatic system, then it is better named as an aliphatic derivative, and here you call this as phenyl substituent. So numbering should be from here, 1, 2, 3. Okay, so what about the name? 3 carbons, so it is propanoic, it is prop, double bond is there at position 2, so it is prop 2 enoic acid, isn't it? Prop 2 enoic acid. And what about the subsequent phenyl at position 3? So 3 phenyl, isn't it? 3 phenyl prop 2 enoic acid. Okay, so that's all. A few examples for nomenclature. Now we will discuss one example for this isomerism. See, we have the, that there are different types of isomerism. Here we discuss only the structural isomerism shown by carboxylic acid. Taking one example. Right? Let me take an example, a simple one, that is this one. Look, CH3, CH2, CH2, COOH. What is this compound? Butanoic acid, isn't it? You can write the chain isomer for this one. This is straight chain without branching. You can keep branched chain like this, right? CH3, COOH. These two are chain isomers. Same molecular formula but different chain, carbon chain. Now coming to another structural isomerism, that is functional isomerism. You change the functional groups, but here you have to keep the degree of unsaturation. You have to maintain degree of unsaturation. That means if the COH can be written as C double bond OH. Look at the degree of unsaturation. That means how many pi bonds are there? 1 pi bond. So when you draw a functional isomer, you have to keep track of this pi bond. You have to maintain 1 pi bond in the structure. Or you can go for ring also. Having 1 pi bond or ring are equivalent. Okay. Now, I can write one functional isomer with a different functional group. Instead of this carboxylic acid, I can make it an ester group, right? Like this. CH3CH2, then COOCH3. You can check these are having same molecular formula. 4 carbons, 2 oxygen, and 1 pi bond, 1 double bond. Another example will be, I can keep, see, a keto group like this CO, right? And the other oxygen can be connected as either as an alcohol or an ether without any unsaturation, because already unsaturation came here. So it will be CH3CH2CH2OH. Check the formula, same. So OH and CO can come. Or you can keep it, make it an ether group also. And another is that you keep 2 OH like this, CH2, OH and another OH, then this double bond should come in between carbon, right? Then this is the another functional isomer. There are 2 OH groups connected, then pi bond comes, double bond comes between carbon. Like that you can write more and more examples, such functional isomers. You can change the position and get what is called position isomers, etc. That's all for now. Okay, in the next class we will discuss about various methods of preparation of carboxylic acid. Thank you.